given n, we need to make two decisions. One, we have to make a recursive call by adding 5 to it. One, we have to make a recursive call by subtracting 5 to it. And initially we have to subtract and then we have to add. And the termination condition for our recursion is that whenever n reaches its own value again, that's where we end, right? So ideally, direction is something that we need an extra parameter for. Now whenever we need extra parameters for recursion, what essentially we do is we write a separate function, because we do not touch existing function. We write a separate function and we call it helper, and the purpose of helper is to add extra parameters whichever are needed for the problem. Now what I'll do here is I'll add a boolean flag or a boolean which tells whether we have to subtract 5 or not, because initially we'll be subtracting 5 and we'll going ahead. And I need one more parameter. This is the number I want to print. I do not want to touch n because I want to use n. Whenever p becomes equal to n, that's where we terminate, right? So this is our first step, and using these two extra parameters we'll go ahead. P will keep on modifying and we'll solve the problem. Now first thing you will see is we'll say print p. Ideally whatever p has come, we'll go and print it. So 16. Yeah, and one more thing is when we make the call to this function, we'll say this is the n you need to take. Subtract 5, initially it is true, yes, we need to subtract. P we are passing as n only initially, right? So we first print p. After printing p, what we do is we have to decide whether we have to subtract again or we have to add again. Now that condition will come if p is 0 or negative. After printing p, what we do is we make a recursive call. If p has actually become negative or 0, we'll make a recursive call, and this time we'll say don't subtract, in fact start adding. So this is what will happen. So recursive call will be made with addition, and in place of p we will be passing p plus 5 as third parameter. So we'll take a look at the code also. Right now this is just the approach that we are discussing. Now imagine if p is not 0 or negative. So what we do is otherwise, so this was the if, else, so this is how we'll make the recursive call. Now the question comes, when do we terminate the recursion? Now recursion has to be terminated as soon as p reaches n, and also after printing that final value of p. So recursive base case we will fit in here if p becomes n and we are on adding path. So we are adding again and again, and we will say sub 5 is false. So this is where we return from the recursion. This is called our base case or confident case, right? So this approach, if we go, we will reach near to the solution, right? So try this approach, go code this solution and see if you are able to nail it.